Base is a blockchain network created to make Ethereum-style apps faster and cheaper to use. It was incubated by Coinbase, but it is not simply Coinbase running a private version of Ethereum. Base is a public Ethereum Layer 2. It processes activity on its own network, then posts enough information back to Ethereum so that the results can be independently checked. That creates a useful middle ground. You get lower fees and quicker responses than you would usually expect on Ethereum mainnet, but you also inherit important parts of Ethereum's security instead of relying on a completely separate blockchain. To understand why Base exists, start with Ethereum's basic limitation. Every Ethereum transaction competes for limited block space. Sending tokens, trading through a decentralized exchange, minting an NFT, or playing an on-chain game all consume computation and data. When demand rises, fees can become expensive. Ethereum could simply make its blocks dramatically larger, but that would make the network harder and more costly to verify. Fewer people might be able to run nodes, which could weaken decentralization. Ethereum's scaling strategy, therefore, pushes much of the everyday activity onto Layer 2 networks, while keeping Ethereum as the underlying settlement and data layer. Base is one of those networks. More specifically, it is a rollup built using the open-source OP stack, the same broader technology family associated with optimism. The word rollup describes the central idea. Instead of asking Ethereum to process every user action individually, Base processes many transactions in its own execution environment. It then compresses information about those transactions and posts batches to Ethereum. Imagine hundreds of passengers sharing one train rather than each hiring a separate taxi. The train still has to pay for the journey, but that cost can be spread across many passengers. Rollups do something similar with Ethereum block space. They combine and compress activity, so each user carries a smaller share of the data cost. This does not mean Base transactions happen secretly somewhere outside blockchain infrastructure. They happen on the Base chain, where Base nodes can execute and inspect them. Off-chain, in this context, mainly means outside Ethereum's main execution layer. Transaction data is still published to Ethereum, so independent participants can reconstruct Base's history. Here is what the process looks like for a normal user. Suppose Maya has ETH on Base and wants to swap some of it for a stablecoin using a decentralized exchange. She opens the app and connects her wallet. The app prepares a transaction, describing the contract she wants to call, the amount involved, her fee limit, and other details. Her wallet displays a request for approval. When Maya confirms, the wallet signs the transaction with her private key. That signature proves that the request came from her address. The wallet does not send Maya's private key to Base, Coinbase, or the app. The signed transaction goes to Base's sequencer. The sequencer decides where it belongs in the transaction order, includes it in a Base block, and sends the result across the network. Base executes the decentralized exchange contract. If the trade succeeds, Maya's balances change in Base's state. Later, Base's batcher compresses transactions from multiple blocks and posts the required data to Ethereum, often using Ethereum's cheaper blob data space. Validators can use that published information and Base's protocol rules to independently reproduce what happened. If explanations like this help you understand what your wallet is actually doing, subscribe. We break down crypto systems without assuming you already speak the language. Base is an optimistic rollup. Optimistic does not mean the system is hopeful about prices. It means state claims are treated as valid unless someone successfully challenges an invalid claim. Base supports fault proofs that allow disputed results to be checked through contracts on Ethereum. This matters because Ethereum does not blindly accept whatever a Base operator says. The rollup posts data. Independent participants can verify the resulting state, and incorrect claims can be challenged. The security model is not identical to placing every transaction directly on Ethereum, though. Rollups add software, bridge contracts, proof systems, sequencer infrastructure, and upgrade mechanisms. Every extra component introduces additional assumptions and possible bugs. The sequencer deserves special attention. Base currently uses a single active sequencer operated by Coinbase. That provides a smooth experience because one operator can order transactions quickly without waiting for a large, decentralized validator network to agree on every Base block first. But it also creates a centralization trade-off. The sequencer could temporarily delay or censor transactions, and an outage could disrupt normal activity. Base includes ways for users to submit transactions through Ethereum, but that route is slower, more technical, and more expensive. The sequencer also has limits. It does not receive your private key, and it cannot create a valid transaction from your wallet without your signature. It cannot simply rewrite history after Base's transaction data has been anchored and finalized through Ethereum. Think of it as a powerful traffic controller, not the owner of every vehicle. This distinction also explains what Coinbase changes and what it does not. Coinbase incubated Base, contributes to its development, operates important infrastructure, and integrates the network into its products. That can make it easier for users and developers to enter the ecosystem. But Base is not the same thing as a Coinbase exchange account. If you hold assets in a self-custodial wallet on Base, Coinbase does not automatically possess those assets. Anyone can deploy a compatible smart contract, and Coinbase does not personally approve every token, game, lending market, or decentralized exchange built there. The familiar name can create a false sense that every Base app comes with Coinbase customer protection. It does not. A malicious token can exist on Base. A smart contract can contain a bug. A fake website can trick you into signing a dangerous approval. The chain can verify signatures and execute code, but it cannot decide whether that code is a good idea. Base also does not replace Ethereum. It depends on Ethereum for settlement and data availability. Nor is it a separate layer 1 like Bitcoin or Solana. Bitcoin has its own consensus network and uses BTC as its native asset. Solana has its own validator network and uses SOL for fees. Base runs an Ethereum-compatible environment and ultimately anchors its data and settlement to Ethereum. That Ethereum compatibility is a major reason developers use it. Apps and smart contracts written for Ethereum can often be adapted to Base without being rebuilt from scratch. The same wallet address can also work across both networks, although balances and contracts remain network-specific. Base uses ETH to pay gas fees. You need ETH on Base, not merely ETH sitting on Ethereum mainnet. Base has explored the possibility of a separate network token, but a separate token is not required to understand or use the chain's normal fee system. Gas is paid in ETH. A Base fee generally contains two economic pieces. One covers execution on Base. The other helps cover the cost of publishing transaction data to Ethereum. Batching, compression, and blob storage can make the combined fee much lower than performing the same action directly on Ethereum. Lower does not mean free or fixed. A complex smart contract interaction costs more than a simple transfer. Base congestion can raise execution fees. Ethereum data costs can change. Some apps may sponsor gas, but that means someone else is paying it, not that computation suddenly has no cost. Now consider how assets reach Base. One option is a bridge. Suppose Maya starts with ETH on Ethereum and uses the canonical bridge to move it to Base. Her wallet first signs an Ethereum transaction. That transaction sends ETH into a bridge contract on Ethereum, where it is locked. Base detects the deposit through Ethereum and credits the corresponding amount of ETH to Maya's address on Base. The asset has not teleported between chains. Ethereum records locked value, while Base records a corresponding balance in its own state. The bridge connects those two accounting systems. Withdrawing through the canonical route reverses the logic. Maya starts a withdrawal on Base. The amount is removed from her available Base balance, and a message representing the withdrawal is recorded. To release the corresponding funds on Ethereum, the system must establish that the withdrawal came from a valid Base state. Because Base's proof design is optimistic, a canonical withdrawal to Ethereum can involve a challenge period. That is why moving funds from Base back to Ethereum through the native bridge may take far longer than an ordinary Base transaction. Third-party liquidity bridges can offer faster transfers by advancing funds on the destination chain, but they add another protocol and another set of smart contract or operator risks. This is one of the easiest misunderstandings to avoid. A transaction can feel confirmed inside Base within moments, while its batch is still moving through later stages of Ethereum settlement. Fast feedback from the sequencer is not exactly the same as final settlement on Ethereum. There are other risks as well. Base's contracts can contain vulnerabilities. Upgrade authority is distributed through governance and a security council, but that still creates different trust assumptions from Ethereum itself. Apps can fail independently of the chain. Bridges can be attacked. Stablecoins can have issuer risk. And sending an asset over the wrong network can leave it inaccessible to the receiving service, even when the blockchain transaction succeeded perfectly. So why does Base attract attention? It combines Ethereum compatibility with lower-cost execution, while Coinbase's distribution and developer tools can help bring users into on-chain apps. That makes Base useful for experiments that would be awkward or expensive on Ethereum mainnet, including frequent payments, trading, games, social applications, collectibles, and other high-volume interactions. The simplest way to remember it is this. Base is a faster execution layer connected to Ethereum. The sequencer gives users quick ordering. Rollup batches reduce the cost per transaction. Ethereum stores the data and supports settlement. ETH pays for gas. Bridges connect balances across networks. And Coinbase plays a major operational role without owning every app or controlling every user's wallet. Base can make Ethereum-based applications more practical, but it does not remove risk, eliminate fees, or turn every project built on it into a trusted Coinbase product. If you still have questions about Base, rollups, sequencers, or bridges, leave them in the comments, and tell us which crypto system you want explained next.